Okay, so for this one, what's different about this one is that the denominator is not fully factored. Okay, so I got to try to do that if I can. It isn't always possible, but with this one it certainly is. So I'm noticing that x squared minus 4 is just the difference two squares factoring pattern, which makes it nice. Okay, so that tells me that's what it's going to break down to. Okay. So that's going to give me some number over x plus 2 plus a different number. Maybe it's different. We don't know that for sure, but I'm assuming. Okay, plus a different number over x plus 1. And that has to equal that whole mess. Let's see if I can grab that. Okay, so I'm going to clear the denominators by multiplying by that great big long um, common denominator. So that's going to leave me an a times now, because I got an a plus 2, that a minus 2, a plus 2 will cancel. So I'm going to leave that times a minus 2 times a plus 1. And then for the b term, the second term, the x minus 2 is going to cancel out. So that leaves me b times x plus 2 times x plus 1. And that's going to, for the last term, the x plus 1 cancels out, which is the product of those two. And if you remember, that was where the x squared minus 4 went. So I'm just going to rewrite that way to save myself some writing. And since we've cleared everything, all that's left on the right-hand side is that polynomial. Okay, and then I'm going to have to do a whole bunch of expansion here. I'm just foiling. I'm doing x squared minus 2x plus 1x is minus x minus 2. And I'll do that same thing here, x squared plus 3x, because of the 2 plus 1, plus 2. And that c can just distribute through very nicely. Oops, it'd be nice if we could write it right, though, LeMay. Let's see. This is the second time I've done this problem, so just so you know. I should learn to do these things on paper first. I wonder if that's what Patrick JMT has done. Okay, so we've got that far, and I'm not writing the right-hand side yet. So now what I'm gonna do is I'm gonna combine my like terms here. And actually, do I have to combine that? Let me just do it this way for you. So 3x squared, and I'm gonna try to write this going down because I'm not gonna have room on the edge of my screen. Okay, so what I've got here is, because remember, I'm trying to break this out into a system of equations. I've got this 3x squared. Well, I've got an x squared term here, I've got an x squared term here, I've got an x squared term there. There must be that the a plus the b plus the c has to be equal to 3, because that's what those the 3x squared terms have to add up to. And then I've got the the linear terms. I've got that negative ax, I've got that positive 3bx. That's where I messed up last time. And this side doesn't have this factor here doesn't have a linear factor, so we're gonna have a 0. That has to be equal to the 3x, so, or negative 11x, I mean. So I'm just going to write negative a plus 3b plus 0, because that last term, this term here didn't have a linear term, has to be equal to negative 11. And then for my constant terms, since those are the only ones that aren't highlighted, I'll just copy those down. Minus 4c equals negative 38. Let's make sure I've got those right. This time I don't have to redo this. All right, that's looking good. So here's my matrix. Just pulling the coefficients off. Notice I've got the 0. Okay, so that's my coefficient matrix. I have my variable matrix. If you want to dispense writing that part of it, you certainly can. 3, -11, and -38. Okay, so this is going to be my A matrix. This is going to be my B matrix. And you can either use that applet or the calculator. I'm going to use the calculator since I already have it in. Now let's see, second matrix, and I'm going to edit my matrix A. Now notice these are different sizes. This matrix, my coefficient matrix, is a 3 by 3. Okay, so that's what I had entered earlier. And then I got to change, let's see, I'm going to change this to 3. And everything else is okay. That's where I had messed up earlier. And then I got to quit this. Second matrix B, I'm going to edit. Make sure I have that in right. So that's a 3 rows, 1 column, and I've got those numbers in right. Okay, so then, let me clear this. So I'm going to grab matrix A, find the inverse of it, grab matrix B, multiply them. So that's what the calculator is telling me the coefficients are. I guess the numerator is not so much coefficients. Okay, the other thing you got to pay attention to is that you don't mix up your order. So I've got an x plus 2, x minus 2, and x plus 1. If you mix up that order when you're substituting in the constants on top or the even expressions, you'll see shortly we'll have expressions. So x plus 2, and that gets the -1, plus -4 over x minus 2, plus 8 over x plus 1. Let's make sure that I think that does it.